In this session, we're covering part 4 of our comparative statistical tests. I want to start off with talking about a little bit about the algorithm. I've posted it in the class. You can see it there. I want to show you how to use the algorithm, and that will be the main basis for this fourth and final section on comparative statistical tests. So if you recall, we start off with what kind of questions being asked. I always start at the top. If I have a question, I look to see which of these groups it best fits into. So supposing we have this question mentioned here. Is there a difference in job satisfaction between BSNRNs and nurse practitioners? So with that question, if I start here descriptive statistics, I would see that it won't fit because for descriptive statistics, it's a how much type of question about only one variable. In the question, we have two variables. We have job satisfaction as one, and we could say type of RN as two, whatever you want to call this. Formal education as an RN, whatever you want to call this variable. But there is a variable here. It could be staff. We have BSNRNs and NPs. So there are two variables. So this question cannot be answered with descriptive statistics. If we look at the correlation group, this is questions about correlations, relationships, and associations. And when I say that, I mean one of those words or some form of it has to be in the question for it to fit in this group. And when I look at this question, is there a difference in job satisfaction between BSN, RNs, and NPs? I do not see the words, literally the words, relationship or related to. I don't see association or associated with, and I don't see correlation or correlated with. So that question cannot be answered with a correlation group. And when we do this, you can think about it, as you've seen in each of these different groups, there are a lot of tests. So just when I looked at this question and I started down the list here, I've ruled out all the descriptive statistics and all the correlation statistics. When I get to considering if it's a comparative group question, the reason why it is because of one word, and that word is difference. If you see a question written in a PICO format, it can only be answered with a comparative group. Remember, the I and the C are two conditions within one independent variable. There's only one outcome, that's a dependent variable. And that right there, a comparison between the I and the C, indicates that this has to be and can only be a type of question that could be answered with the comparative group. But so, imagine that we're in class, somebody says, hey, I have a research question I want to study, and we say, what's your question? And they start to say, is there a difference in? When they get to the word difference, we can rule out the descriptives, the correlations. We can rule out the regressions because these are about prediction. We don't see the word prediction in here. It's not about a rate. It's not about likelihood, odds, probability, or risk. So it doesn't fit into the epidemiology group. So the question, is there a difference in job satisfaction between BSNRNs and NPs, can only be answered with a comparative group. And in the full version of my algorithm, what you would do, you would start off on this slide. When you came to this slide and the third group and said, hey, this question fits with the comparative group, you're directed to go to slide 14. So you skip ahead to slide 14. And I'm going to come back to that in a second. So we start off with the study. We want to know if there's a difference in job satisfaction between these two levels of nursing. So we go out, we measure their satisfaction, we identify them as which group they belong to, and then we see if there's a difference. And that's how that test would run. So we would be collecting data, and I've been mentioning this, and I want to take a second to explain what that looks like. So on this slide, and I know it's small, I have an example of a data set that I created in SPSS. And this is a standard format that we can develop in Excel and push into SPSS. It'll take it up directly if we have it structured well. And I want to go over this really quickly to show you how this is set up. First of all, in row 1, we have our names of our variables. We have age, education. We have height, weight, BMI, BMI group, systolic and diastolic blood pressure, temperature, pulse, so forth and so on. Each row is a participant. So on row 2, we have participant that we just called participant number 1. They're 20 years old. Their education level is 1. On another sheet, it would explain what the 1 is. But this is ordinal data. Like the 1 might be that they're an LPN. Maybe 2 is they're an ADRN, 3 a BSN RN. And that's what we would be looking at with this. We have their height in inches. So participant number 1 was 66 inches tall, weighed 120 pounds, and had a BMI of 19.4. This is what a data set looks like. And the characteristics of the data set is that we have our variable names in row 1 across the top. Each row is a participant, and this could go down to hundreds of participants. But all of our data is in numbers. All of our data is in numbers because SPSS cannot read words. So we have to use coding. If we have ordinal and nominal data, we use numbers to code for that, and then we explain in another sheet what these codes indicate. Like over here, just as an example, for smoking history in this particular study, 0 represented never smoked, and 1 represented smoked but quit. And actually, number 2, which you don't see here, 2 was that they were still smoking. So that's an example of how we create a data set. After we have our study question, we go out, we collect our data. We can track it in Excel. We can upload that to SPSS. And then, like I've been saying, we press a few buttons and we get our results. So with our descriptive studies, remember with descriptive statistics, if on here we said that our question is at the descriptive level, it would send us the slide 9. This is slide 9. And all I'm showing here is that we can get the mean with scale data. Our best central tendency measure with ordinal data is median. And the best central tendency measure with nominal data is mode. With nominal data and ordinal data, we cannot obtain a scale. We cannot obtain a mean. We can only get a mean from scale data. So if we are measuring our dependent variable in nominal and ordinal data, we cannot calculate a mean. We cannot use a t-test or ANOVA. And that's what I'm trying to show here. And again, remember, I've been saying this, that the level of data determines which tests we use. So if we have scale data, it might be the independent samples t-test. If it's ordinal data, we can't use the t-test, can't obtain a mean. We would use the Mann-Whitney U. And if it's nominal data, we could go with chi-square. Focusing then on the correlation test, if on the algorithm we found that our question is a correlation type question, we'd be directed to slide 11. This is slide 11, and it basically explains when we use our different tests. Like for example, the Pearson's R can only be used with scale data. So if we have a correlation question and our data is both variables are in scale data, we use the Pearson's. If both variables are in ordinal data, we use Spearman's. If both variables in nominal data, we often use the phi. It's listed in here. If one variable is in scale data and the other is in nominal data, we use the point by serial. So within this, if we can identify our question as being a correlation question, and then we can turn to slide 11, we can look at our variables, determine how they're being measured, and we can see which is the most appropriate test. I showed in a prior class, I showed you the version of the structural equational modeling that we might use in a theory to show how various concepts are related to other concepts within that theory. If when we're deciding what kind of question we're being asked, if we do indeed decide that it's a comparative type question, we're directed to slide 14. And this is where slide 14 begins. And before the end of the class, I will share the completed algorithm with you as a resource that you can use. I would not expect you to memorize this, but just to understand some of the basics of it. For example, that we need scale data to run a t-test or a ANOVA. If we have ordinal data, we have to run a different kind of test, that kind of thing. But you can follow this. Once you've identified a question as being a comparative type question, you would come to this particular slide. And the first question we ask with our comparative group is, how many conditions does the independent variable have? And if you remember, we talked about this. If it's 2 or less, we use the t-tests. If it's 3 or more, we're going to use the ANOVAs. Under the t-test, if it's a pre-test, post-test design, we go with the paired samples t-test or the Wilcoxon or the chi-square. If it's not a pre-test, post-test design, we go with the single sample t-test, independent samples t-test, the Mann-Whitney U or chi-square. If we have 3 or more conditions being compared and the independent variable, we then also have to ask if it's a pre-test, post-test. If it is, we'll use the repeated measures or the Friedman's or the chi-square, Cochrane's Q, or all the tests in this group. If it's not a pre-test, post-test design, then we simply use one of the ANOVAs. If it's not in scale data, we use Kruskal-Wallis. If it's nominal data, we use chi-square. So for each of these, what we do is when we come to this box, we're directed to slides 16, 17, 18, or 19. And that's how we're going to finish this off. So slide 16 looks like this. I think that's what this is. Yep. This is slide 16. They're not numbered here because I've left out some material that's in between these. So when we get here, we basically have narrowed our test down to being the paired samples t-test, the Wilcoxon or the chi-square. So here we ask what kind of data is in the dependent variable, and we can see if it's scale, we can use the paired samples t-test. If it's ordinal, it's the Wilcoxon. If it's nominal, it's chi-square. And I mentioned rates. If it's rates, it's a Z-score for 2 population. If we got to our second box, this was this box. It's not a pre-test, post-test design. We're directed to slide 17. So here we have the single samples t-test, the independent samples t-test, and the Mann-Whitney U. And again, the determination of which of these tests is used is how we measure our dependent variable if it's scale, ordinal, nominal. We can only use a t-test if we have scale data. In this case, if it's ordinal, we'd use the Mann-Whitney U. If it's nominal, we'd use chi-square. Back to this original part of the algorithm, if we go all the way back. So if we're in the comparative group, if our question comes up under that, we're directed to this slide. And in the situation where we have more than 2 conditions within our independent variable, we're going to use what I call the ANOVA track. And this will be slide 18 and 19 that we're directed to. If it's a pre-test, post-test, we're going to go to the repeated measures ANOVA, the Friedman, the chi-square. And again, when we get here, we just simply have to know how our dependent variable is being measured. If it's scale, we can use the repeated measures ANOVA. Remember, the ANOVA, like the t-test, compares means. We can't get a mean if we don't have scale data. And so in that situation, if it's ordinal, we use what's called the Friedman test. If it's nominal, we use Cochrane's Q, which I don't really see used that much. If it's not a pre-test, post-test design, and we come along this bottom track, we're directed to slide 19. And this is what slide 19 looks like. These are our basic ANOVAs. And here we see if depends on how many independent variables we have. If we have 1, it's a one-way ANOVA. If it's 2, it's a two-way ANOVA. If we have any number of independent variables, we have that way ANOVA. Then we get into some interesting situations. If we have more than one dependent variable, and that comes up sometimes with our ANOVAs that are just, remember, incredible multitaskers, we use what's called a MANOVA. And if we have a dependent an IV, a DV, and covariates, we have what's known as an ANCOVA. And there are many more ANOVAs, These are just some of the samples of the ones I see most commonly used. When we get down to the chi-square, and this we'd be directed here at another point in the algorithm, then we have to find out about our cells. Remember I showed you the cross tabulation. If we don't have any zeros in our cross tabulation, um, no more than one cell less than 5, we can use the chi-square. But if those assumptions are violated, we can use the Fisher's exact test. The Fisher's exact test is a little bit more conservative measure of p-value than chi-square. So what we're going to do in the second half of this course, when we come back, we're going to look at studies, we're going to look at questions, and we're going to try to take that question and the way the variables are measured, the number of independent variables, and we're going to take them through the algorithm and see how they hold up. So that's the purpose of this algorithm, is if you had a study, you could come to it and working your way through the algorithm, looking at the type of question being asked, then asking questions like what kind of data do we have in the dependent variable, you could come out with determining which is the most appropriate test to use in that study. This concludes our discussion on comparative statistical tests.